Hello space enthusiasts. Welcome back to Daily Space Marvels. Today, we're diving into the scorching mystery of Venus. Despite being farther from the Sun than Mercury, Venus is the hottest planet in our solar system. Intrigued? Stick around, and by the end of this video, you'll know why Venus outshines Mercury in the heat department. Don't forget to like this video, activate notifications, and subscribe to our channel for more amazing space facts. Let's get started. First, let's get to know our two celestial neighbors a bit better. Mercury is the closest planet to the Sun, orbiting at an average distance of about 58 million kilometers, 36 million miles. It's a small, rocky planet with virtually no atmosphere to speak of. Because of this, temperatures on Mercury can swing wildly. Venus, on the other hand, is the second planet from the Sun, orbiting at an average distance of about 108 million kilometers, 67 million miles. It's slightly smaller than Earth and is often called Earth's sister planet due to its similar size and composition. But that's where the similarities end. Venus has a thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid, creating a runaway greenhouse effect. To understand why Venus is hotter than Mercury, we need to delve into the greenhouse effect. The greenhouse effect occurs when a planet's atmosphere traps heat from the Sun, preventing it from escaping back into space. This trapped heat causes the planet's surface temperature to rise. On Earth, the greenhouse effect is essential for life. It keeps our planet warm enough to sustain liquid water in a habitable climate. However, on Venus, the greenhouse effect has run amok. Venus's thick atmosphere is around 96.5% carbon dioxide, a potent greenhouse gas. This means that almost all the heat from the Sun gets trapped, resulting in surface temperatures that average around 467 degrees Celsius, 872 degrees Fahrenheit, hot enough to melt lead. The key difference between Venus and Mercury lies in their atmospheres. Mercury has a very thin atmosphere, composed mostly of trace amounts of hydrogen, helium, and oxygen. This thin atmosphere is unable to trap much heat, leading to the extreme temperature fluctuations we mentioned earlier. Venus, however, boasts a dense atmosphere with a surface pressure about 92 times greater than Earth's. Imagine being submerged nearly a kilometer, 0.6 miles underwater. That's the kind of pressure you'd experience standing on Venus's surface. This dense atmosphere doesn't just trap heat, it also distributes it evenly across the planet, eliminating the drastic temperature differences between day and night that Mercury experiences. Another factor to consider is albedo, which is a measure of how much sunlight a planet reflects. A higher albedo means more sunlight is reflected and less is absorbed, which can affect a planet's temperature. Mercury has a low albedo, meaning it absorbs most of the sunlight that hits it. Venus, surprisingly, has a high albedo due to its thick, reflective clouds of sulfuric acid, which bounce much of the sunlight back into space. You might think this high albedo would cool Venus down, but the greenhouse effect far outweighs this reflective property. The thick clouds do reflect sunlight, but they also trap heat incredibly effectively, leading to the extreme surface temperatures we see on Venus. To fully understand why Venus has such a hostile environment, we need to look at its history. Venus likely started out with conditions similar to Earth's, including liquid water on its surface. However, over time, a combination of volcanic activity and the loss of its magnetic field led to the thick carbon dioxide atmosphere we see today. Volcanic activity on Venus released massive amounts of carbon dioxide and water vapor into the atmosphere. Without a magnetic field to protect it, solar winds stripped away lighter molecules, like hydrogen, leaving behind a dense atmosphere rich in greenhouse gases. This runaway greenhouse effect transformed Venus from a potentially habitable world into the hottest planet in our solar system. Understanding Venus is crucial for several reasons. First, it offers a stark warning about the potential consequences of a runaway greenhouse effect. While Earth's greenhouse effect is currently balanced, increasing levels of carbon dioxide from human activities could tip the scales, leading to more extreme weather and climate conditions. Second, studying Venus helps scientists better understand the atmospheres and climates of exoplanets, planets orbiting stars outside our solar system. By comparing Venus's atmosphere and climate to those of exoplanets, scientists can refine their models and predictions about the potential habitability of other worlds. In recent years, there has been a renewed interest in exploring Venus. NASA's DaVinci Plus and Veritas missions, scheduled for launch in the late 2020s, aim to study Venus's atmosphere and geological history in unprecedented detail. These missions will provide valuable data to help us understand how Venus became the hellish world it is today. The European Space Agency ESA is also planning a mission to Venus called Envision, which will focus on mapping the planet's surface and studying its geology and atmosphere. These missions will not only advance our knowledge of Venus, but also improve our understanding of planetary climates and atmospheres in general. Venus has long fascinated humanity, appearing in countless works of fiction and art. From ancient mythology, where Venus was the Roman goddess of love and beauty, to modern science fiction, Venus has captured our imaginations. While early science fiction often depicted Venus as a tropical paradise, we now know it to be a scorching, inhospitable world. Despite this, Venus continues to inspire stories and dreams of space exploration. Venus's deadly beauty lies in its extreme climate and harsh conditions, providing a captivating study in contrasts. Despite being farther from the Sun than Mercury, Venus's thick carbon dioxide atmosphere creates a runaway greenhouse effect, making it the hottest planet in our solar system. By studying Venus, we gain insights into planetary climates, the potential consequences of climate change, and the nature of exoplanets. Thank you for joining us on this fiery journey to Venus. If you enjoyed this video, please give it a thumbs up, activate notifications, and subscribe to Daily Space Marvels for more incredible space facts. See you next time.